the same, but it just takes a little bit longer to work out, and you have to be a lot more careful with your method. So we're going to start off with the decimal number 1,000. And we're going to use that little number 10 to denote that. And we're going to convert this number into binary. So because we're converting into binary, we need to put our place values along, starting at the right and working up in powers of 2 from right to left. Now, I'll give you a little tip here. Keep going, writing all these place values, going up in powers of 2, until the next one to right would give you a number bigger than the number you're trying to convert. And that's the point you stop. So we'll keep going, 16, 32, 64, 128, 256, 512. Now, the next number, if we times that by 2, gives us 1,024, which is bigger than this number. So we know that's the point at which we stop. And from here on out, it's exactly the same method. You start on the left and you work right. Does 512 fit into 1,000? Yes, it does. We deduct from 1,000 that place value, 512, and that gives us 488. Our new number, does 256 fit into 488? Yes, it does. So we deduct from 488, 256, which would give us 232 as the next one. Does 128 fit into 232? Yes, it does. We then can deduct 128 from 232. I'm just going to do some long subtraction here. And that gives us 104. Does 64? So our new number is 104. I'll square that for you so we can see that. Does 64 fit into 104? Yes, it does. And that's nice and easy to work out. You've got 40 left over. Does 32 fit into 40? Yes, it does. So we deduct 32 from that number and we get our new number 8. Does 16 fit into 8? No, it doesn't, so we put a 0. Does 8 fit into 8? Yes, it does. We deduct 8 from our number, giving us our new number of 0. Does 4 fit into 0? No. Does 2 fit into 0? No. Does 1 fit into 0? No. And there we have it. The decimal number 1,000 is equivalent to the number 11111010000 in binary. Let's take a look now at converting some larger numbers into hexadecimal. Let's take the number 9,371 in decimal and convert it into hexadecimal. Same method when coming up with the right place values. You start on the right and you work left. 16 to the power of 0, which is 1. 16 to the power of 1 is 16. 16 squared, 256. 16 cubed is 4,096. Now I know that if I times 4,096 by 16 to give me the next place value, that would definitely be bigger than 9,371. So I can stop there, and now I work from left to right. I ask myself the question, if you want to stop the video now, by all means, stop it, work this out, and then you can follow along with this method to check your answer. We ask ourselves the question, how many times does 4,096 fit in to 9,371? Or put another way, if I divide 9,371 by 4,096, what is my whole part and what is my remainder? Now I can see that this goes in 2 times, and to work out the remainder, I do in the same way that you've been taught in maths. You do your whole part times the number you divided by and deduct that number from 9,371. So I know that 4,096 times 2 is equal to 8,192, and then I do 9,371 minus 8,192. 1,179 is my remainder. So I put that in here, and this is my new number. I'm going to square it to see. Now the whole part I put in here, 2, and then I use my remainder as I move over to the next place value. We ask ourselves the question, how many times does 256 go into 1,179? Or, if I divide that by 256, what is my whole part and what is my remainder? Now I can see that this goes in 4 times. So I'm going to put my 4 in here, and then I'm going to calculate my remainder in the same way. I know that 4 times 256 is 1,024. You could use a calculator if you like. And then I'm going to subtract that from my original number to work out my remainder, which is 155. I can put that in there and square that to know that's the one I'm now looking at. I move along one place. How many times does 16 go into 155? Or 155 divided by 16, what's my whole part and my remainder? Now I know that that goes in 9 times. So I'm going to put 9 in here, my grid, and I'm going to calculate my remainder. So 9 lots of 16 give me 144, and I deduct 144 from 155. I can do that in my head, that's 11. So my remainder is 11. I've come to the last column in my number. How many times does 1 go into 11? What's 11 divided by 1? Well, it's just 11. But of course I can't write 11 there because that would be using 2 symbols, 1 and 1. We know that in hex, 11 is equivalent to the symbol B. So we put B in. And that is our hexadecimal number that we've converted from this decimal number. You may find it helpful to keep a little grid of what those letters equate to when you're doing this, so that when you get a number like that, you can go, oh, 11, that's B, or 14, that's E.